If you are planning to become a data scientist or data analyst, you must speak the language. In this video, I'm going to be talking about 25 technical jargons you need to know that every data analyst speaks so that you're able to speak confidently to other data experts or to your recruiters. First of all, welcome to my cyberspace. Now let's get right into it. I'm going to be talking about 25 technical jargons you need to know, and these are things that you will literally hear every day. And let's just go into the number one. So number one is role. So role is the horizontal alignment of your data representing individual observation and entry. So horizontal alignment, in case you're not sure what that is, it literally means like the way it is like this going on this like line. I would not use the word straight line, but think of it like horizontal alignment. So when you see a data set and there's like when they are talking about rows, so that is what you mean. So if you probably went to some high school or whatever, a lot of times when the teacher asks everybody on this row stand up, so think of it in that reverse direction. So what they actually meant is everybody on this column stand up. And going to the next point, which is column. So column is the vertical alignment of your data. So literally, so when the data goes like this, so what you see is the column. Is a column. So I'm going to show you an example for you to have a better picture. Also, the data set is all of the collection of your data presented in a tabular form comprising rows and columns. You would often hear data and data sets used interchangeably, so don't be confused if you hear the term data or you hear the term data set. Another one is variable. Variable is a characteristic that could be measured or vary between entities. So typically it is represented by column headings. So remember that the column is just on a vertical line. We have sex and we have age. So let's give a perfect example and see if you could know what the role is and the column and data set and the variable is. So try to pause this video and see if you can catch what the column, the role and the variable is. But I guess you did pause the video. Now let us try to see. So this is the column. This is column 1, column 2, column 3. And in this column, we have the age, the sex, and the income. So when we talk about row 1, this is row 1. Everything here is row 1. Everything here is row 2. Everything here is row 3. Everything here is row 4. Right? And everything all together, all of this is the data set or is the data. So what do you think about the variable? The variable is also the sex, income, age. Those are the variables. I hope you got that, so at least you're very confident when somebody mentioned rows, column, data sets, and variables. Now let's go to the next one. Code book. You heard the term code book, so you need to also use this term when you are talking to people so that they have an understanding that this person knows what they're saying. Code book, this is literally a document or file providing detailed insight into the variables within a data set. This is also known as a metadata or a data dictionary. So a code book is a data that describes a data. So I will show you an example. When you have a data set, let's say it's on gender, the name is gender and they categorize as 1 and 0. You might not have a perfect understanding of 1 is male or 0 is female. Also, if you have something like num, you don't know what that is. And there are some variables that just because of the convention of naming a variable, you can't make a variable name very long. So there's a code book that will describe what the data is, also maybe the data collection. So when you are speaking to somebody and they give you a data set and you're asking them, what does this data mean? And you need one of the things you can say, is there a code book? Is there a documentation? Is there a metadata? So all of those terms to really make you sound like you know what you're saying. Another thing is sample. And sample is a subset of elements from a larger group selected for a study or analysis. A lot of times, except you're working for working with real-time organization data, you are using a sample data set. A sample is the way it sounds, and if it's not a sample, it's a population, and that goes to the next point. So population is a complete set of a group that we're interested in studying. So when we think about population, we're not just thinking about the population of a country. If you're interested in studying maybe 100 companies, so the population there is 100. If you collected the data 100 companies and you then analyze 30, then that is the sample. But most of the times it necessarily might not be what that case is. Think of it as when you want to carry out a census. Most countries will carry out census once every 5 years or 10 years, but they can't keep carrying out census on everybody, because in itself it might not be very reliable if you try to carry out that much census on everybody. So that's why they kind of form like a sampling techniques to be able to get a bright representation of the data. So I don't want to go into details not to complicate things, but the next one is a database. Database is an organized collection of data, usually stored electronically. So think of it as a library where you pick different books and it's stored in different sections. If you use SQL very well, you have a perfect understanding of what this database is. So that's just what it means. There's visualization, representation of your data in graphs and tables. We also have dashboard. It's a way of displaying different types of data visualization in a simple snapshot. And we have query. So this is to request for a data in a database. So when you write a SQL query, some people call it your code or whatever it is. Those are some of the terms that you will get to hear as a data expert. So let's do some practice of what is a query, what is a population, what is a data set. So first of all, you remember that we know what a variable is at this point. This is the description, this is the levels. So this is a code book. This is showing that the variable age, it means age as first marriage. It's not just age. So you can't just jump into conclusion. Why ma actually means marital status, income means income before tax. And they then start to explain that. So it goes from 0 to 5, 50,000, and 999 means no response. So that's why as data experts, we need a code book. Now, this is a population, everybody, and sample is just a sub of it. This is a dashboard, right? And each of this is a visualization. This is a visualization, this is a visualization. So a collection of like visualization, if it's something like this interactive, is actually called a dashboard. And this is a crook or like example of thinking of how a database would look like. Think of it as a library, but this is something that is stored electronically or digitally. I hope you are getting that. Next thing, also you get to hear something like X or Y or Z. So but let's just stick with X and Y. So X really usually denotes as the independent variable or the predictor, and Y usually denotes the dependent variable or the outcome variable. This is a little bit confusing for like beginners, but in the sample I'm going to show you, you would have a perfect understanding of what I meant by that. So why the Y-axis is the horizontal part of a graph. You need to also be able to understand what is horizontal, what is vertical. So this is the horizontal part of the graph, which is the y-axis. The y-axis is the horizontal, which is like this. Why the y-axis is the vertical part of a graph. Hypothesis is an educated guess about the expected outcome of a data analysis. So one of the things you can do for yourself is pause this video, try to look at these very well so that you would know them by heart. Also, there is something called correlation and association. This is the statistical measure examining the relationship between two variables, saying when they say is there a correlation, so they're asking is there a relationship, are these variables associated with one another. Another thing also is regression. This is a measure examining relationship between two or more variables. It's similar to correlation but a little bit advanced. The next point is causation. So this is to make a bold claim that X and Y are not just related, but X causes Y. And that's something you really don't want to do so much as a data scientist or social scientist. You really want to have your facts ready to make a causation claim. There's models or modeling. This is just a mathematical relationship between two variables, and this depends on the context that you're meaning. Sorry, somebody can say model and they're saying different things. So but let's try to just have a perfect understanding of the x-axis, the y-axis, and hypothesis. So this is the y-axis, which is drowning, and this is ice cream. So what this is saying is, if you want to look at from a correlation causation, we can say that as ice cream increases, as the sales in ice cream increases, people also drown more. Then you're like, how is this related? And we can now start to think about what are other explanatory variable. Because it's ice cream, maybe it is in the summer period, so people will buy more ice cream. Then people go to the beach more, then they get to drown. So there's a association, doesn't mean there's a causation. So that's something you could think about. Then the X, the independent variable here, which is the independent variable, what do you think can cause this? What can cause drowning is ice cream. So you can't say drowning is causing ice cream sales. So it doesn't make sense. You can't say like people are drowning more, that's why we are getting increase in sales. But you can still say, oh, maybe because there's ice cream sales more, then people are drowning. That makes sense a little bit logically. So what is the, in quote, the cause? Remember, I'm putting in quotes, is always the X, which is ice cream, or the drowning, right? So then you can, this is a flip script now, which is like which is another one of crime rates. So this is crime rates, this is drowning. So it just depends on how you're thinking about things. And when you talk about like hypothesis, the null hypothesis, when you get to hear terms like null hypothesis, you will say there's no relationship between ice cream sales and crime rates. And the alternative hypothesis means there's a relationship between ice cream sales and crime rates. So let's move on to the next. And this is analysis. When you get analysis, we're just talking about like any process of making sense of data. That could be as simple as using Excel or just looking at the data set, and you'll be able to know that that's an analysis. There's data wrangling. All of these are just terms to say you are manipulating your data. And when you hear the term manipulation, don't think it's a bad word. Manipulation is just trying to transform the data. So it's collecting, transforming into like the structure that will be needed for analysis. There's also cross tabulation. So it's really a table where you represent the results of the entire group, most likely like two categorical data and all of that. There's also the term called statistics, which is like the study that the study field that organizes data. This is concatenate. When you get it yet concatenate, it means to join two data sets together. So don't allow that term scare you. We also add the term filter. I think this is a little bit simple. You some platform will use slicer, some will use filter. It's still the same thing. Set condition to select a part of the entire data. Let's say, oh, you have a data for male and female, like I just want to select male alone, and that is what is just going to show for you. There's sorting. This is to arrange your data set in the desired format. So let's quickly see an example of like data wrangling and cross tabulation. This is a cross tabulation in itself, and this is now we're trying to sort this data. So we see that this is if we want to like merge these two data. We have this data for sex, income. This is a different data, and this is another data. Imagine I want to know what is the particular rurality for this ID 1001. I just have to merge these two data together. So I would say I'll merge these two data sets on the IDs. So that is how merging most likely works. There are sometimes you would also have to stack a data. Imagine I have this 1001 to 1005, and I have another one 1006 to 1009. You just have to stack them on each other. So understand the different types of join that you're doing and know that it's going to be very helpful for you. And the next one is I think that's pretty much it. So we've gotten to the end of this. So try to know all of these terms, and when you know them, it's just going to really help you to be more confident in your conversation as a data analyst. And one thing I wanted to mention, which is very important, is categorical and numerical variable. A simple way to differentiate that is categorical variables are more of like texts. Variables, they are mostly text, while numerical variable are mostly numbers. Doesn't mean that a variable that is a number would not or cannot be a categorical variable, but that's one way, because the analysis you can run for a numerical variable is same from the analysis you can run from a categorical variable. In the other videos, I'm going to be talking more about like some of the ways or the thinking process of a data analyst when it comes to categorical variable, numerical variable, and so that when I get to use all of these terms that I've mentioned today, it's going to be very familiar with you. So go back again and watch this video, and thank you for your time. Ciao.